Here we want to find a number e such that the integral from 1 to e is 1. We have learned that the ln of x, definition of ln of x is the integral from 1 to x of the function 1 over t. And so ln of e is the integral from 1 to e. And so e is a number such that this area right here, the area between the graph of 1 over t and the x-axis, is equal to exactly 1. And so we're looking for a number that we would put here. We're looking for an upper limit of integration such that the integral from 1 to the number e is equal to exactly 1. And so now let's go look at the area and see if we could find what e is. And so right now we have natural log of 2.6. And so by definition of natural log, this is the integral from 1 to 2.6. So it's 1 here and then 2.6 here. And this area is 0.95. And the function is 1 over t. And so if we go up to 2.7, then we get 0.99. So the integral from 1 to 2.7 is 0.99. Again, we're looking for an upper limit of integration such that the area is exactly 1. And so we go to 2.8. Now the area is more than 1. And so it looks like the number e that we're looking for is somewhere between 2.7 and 2.8. So let's go back down to 2.7. And this is 2.71. The natural log of 2.71 is 0.99. And so it looks like it's a little bit more. Let's see if we can get closer. And this is the natural log of 2.714, and the area of this shaded region here is 0.9984. So it looks like we're getting closer. So again, we're looking for a number. We're looking for this upper limit of integration right here, such that the area is exactly 1. That's what we're looking for. So there's more than 1. So let's go back down. So we're getting closer. And so it looks like E is the number 2.71828A1A28. And this is still not exactly 1. But if we keep going and just keep searching and searching, then what is going to come out is this, the number with this long. And so we got 2.718281828, which is to about right here. And if we keep going, the next number we're going to get is 459045, and so on. And this is not the end of it. E is an irrational number, which is like the pi number is an irrational number. and it would just keep on going forever. So that's what E is. E is a number that's approximately this. And so from the graph, we found that E is approximately this number, 2.71828182845, and so on. And so that's what the number E is. And now we want to get the definition for the exponential function that has E. So a function like y equal to e to the x, where e is this number right here, we defined it where it's defined as follows. Y is equal to e to the x if and only if x is equal to the natural log of y, where x is just any real number. And so now let's go look at the graphs of the function y equal to e to the x and the function y equal to the natural log of x. And this is the graph for y equal to e to the x, and this is the graph for y equal to ln of x. And if we draw the what's called the diagonal line right in the middle, then what we see in here is that the inverse function of the natural log function is the function e to the x, and vice versa. And the inverse of function of the e to the x of the function y equal to e to the x is the function y equal to the ln of x. And so that's the relationship between the exponential function and the natural log function, the inverses of each other. And next we want to find the derivative, meaning we want to find y prime, the derivative b to the x. But notice the following. So from this function right here, if we take the natural log of the left and natural log of the right side, then we have ln the natural log of e to the x is equal to ln of e to the of y, but ln of y is equal to x, and therefore ln of e to the x is equal to x. And now we want the derivative of the function e to the x. And so we have the, so we just got this result here, ln of e to the x is equal to e to the x. And so now we take the derivative of both sides. And this is the derivative, the left-hand side is equal to the derivative of the right-hand side. And so we know that the derivative ln x is just 1 over x, but here we have the derivative of ln e to the x, and so we have to use the chain rule. And so the chain rule is to be 1 over e to the x, and times the derivative of e to the x, and then on the right side, the derivative of x is just 1. And then now multiply both sides by e to the x. And we end up with the derivative of e to the x is equal to e to the x. And so, which means, so the derivative of e to the x is equal to e to the x, same thing. And so, which means the antiderivative of e to the x is also equal to e to the x plus c.